Hey guys, welcome to section 1 and section 2 of chapter 8. These sections are pretty simple and straightforward, so I thought I could probably combine both of these videos into one. So hopefully the first part is just a review and the second part just a little application of it. In this chapter, we're going to start out reviewing ratios and proportions. You're going to need a calculator for some of the problems in your homework. If you hadn't been using a calculator, good for you, but you are free to use a calculator in this course. Then you can also leave your answers in either decimal or fraction form, whichever you're more comfortable with. For your homework tonight, they're going to ask you to solve some basic ratio and proportion problems. So if you have a situation like this, you might remember from your early days of pre-algebra, we would cross multiply and set them equal to each other. So we would have 3x equals 36, divide both sides by 3, and x would equal 12. Okay, so when you have proportions, their cross products are equal. So these are called the cross products, and they're equal to each other. All right, and then all we have to do is solve. Okay, so here's another one. If we set cross products equal to each other, we would get 2x equals 66, and x would equal 33. So those are really easy, especially if you were using a calculator. All right, but there's going to be a few of them where you have more than one term in either the numerator or denominator. And the key is you need to make sure that if there's more than one term, you have parentheses around them when you multiply the cross products. So we would have 5 times 10, which is 50. And then when we do this cross product, it would be 4 times the quantity x minus 4. Now we have to remember to use the distributive property when we're solving for x. And then if we add 16 to both sides and divide by 4, you're going to get 16.5 or 33 halves, whichever you would like. All right, similarly for this guy, if you have more than one term, make sure you put parentheses around them. And it's fine that we have more than one term with an x in it. As long as it's just a single variable, we can still just set cross products equal to each other and solve, because we know how to solve equations with variables on both sides. So we would get 3x equals 5 times the quantity, x plus 1. So 3x is going to be equal to 5x plus 1. Now you can go either way. If you subtract 5x from both sides here, you're going to get a negative 2x equals 5. And x is going to equal negative 5 halves. You could have subtracted the 3 and minus the 5 to the other side, but you would have gotten the same thing. Okay, literally that's your whole homework tonight. So that's really straightforward. Hopefully you guys have done cross products before, and this assignment is going to be super easy. All right, at this point you can shut off the video and do your assignment. Resume at this point tomorrow for 8.2. All right, guys, 8.2. In this section, we are going to talk about similar polygons. And look at that tiny little s there. That's hilarious. All right, and we can know that polygons are similar if two things exist. One, corresponding angles have to be congruent, and two, corresponding sides have to be in proportion. So we're going to use our practice of proportions from yesterday to check to see if our sides are in proportion, and then of course we just have to check to see if our angles are congruent. If both conditions are met, the triangles are similar. You're going to notice a different sign today. Before, we've been using a lot of this sign, which equals congruent, but the similarity sign is just the little squiggle. Okay, so for this example, first of all, I'm going to check corresponding angles. Those angles are congruent, these angles are congruent to each other, and these angles are congruent to each other. So angles are congruent, check. The next thing I have to do is grab a set of corresponding sides and see if their cross products are equal. it doesn't matter what sides you grab as long as they're corresponding, right? They hold the same position. So if I grab 18, its corresponding side in the other triangle would be 30. And we want to know, is that congruent too? And it doesn't matter, you can grab either of the other sides, but they have to be corresponding. 24 over 40. Now we're going to check cross products. So if I check 18 times 40, I'm going to get 720. And if I multiply 30 times 24, I'm also going to get 720. And so those sides are in proportion. So my congruent statement would look like triangle, and again, you can do any order as long as they're both corresponding. KLM is similar to triangle QRS. All right, so for the shapes that you're checking to see if they're similar, you're checking their angles, you're checking their sides, and then you're writing the similarity statement. Okay? All right, let's look at this guy. First off, we're going to check our angles. Our angles for the first shape are all 90 degrees. The angles for the second shape are all 90 degrees. So that's super easy. Angles are done. Now we have to check to see if our sides are in proportion. So grab one set of sides that are corresponding. And then grab another set of sides that are corresponding. And perhaps your instinct is going to tell you that this is not going to work out for us, as it should. Then we multiply. 6 times 4 is 24. Is that equal to 48? No. So these shapes are not similar because those sides are not in proportion. Okay? All right, let's check another one. All right, in this example, if you're doing our angle test first, you see that all of these angles are 90 degrees, but look at this angle. That angle is 60 degrees, which means it is not congruent to its corresponding angle. So right away we can say not similar. Corresponding angles have to be congruent. This is why I generally start with checking the angles to see if they're congruent, because if the angles are not congruent, then right away we can say that the shapes are not similar. All right, then let's look at this example. This, obviously, we have an unknown here. So in some of the shapes, they might say to you, all right, the shapes are similar, so solve for the unknown side. So if they're similar, we know that their sides are in proportion, which means I have to find the corresponding side to the variable that I need. So it might be helpful to notice, all right, there's my one congruent angle and my 90 degree, and the side is between. So my corresponding angle with x has to be 16. And it doesn't matter if you put x on top or 16 on top. You just have to make sure that you're consistent when you grab your other side. So then I need, we could try the hypotenuse. That might be easy to identify. And I did big triangle first, then small triangle. So my big side goes first, then my small side. Okay? So checking proportions and similarity, you just have to make sure that we're using corresponding sides and we're keeping things consistent. So it doesn't matter which direction you go, as long as you make sure that whatever shape you start with, that remains on top and the second one remains on the bottom. Okay, now we're just solving like a regular proportion. So it's going to be 20x equals 560. And if I divide by 20, I'm going to get 28. Okay, that's it. I could do 1,000 examples. I didn't think you guys probably needed it. This seems like really straightforward. I think you should be fine. So when you're ready, go ahead and finish up your notes, read through the examples, and begin your assignment.